Is it working? You hear me? Yep. Very good. He said that he was not very professional in those here, and I'm not either. So, but I think we will survive. Anyway, start to present myself. Here we go. I am segment director for the area Subsea and floaters in DNV. And that is, to me, a new role from 15th of February this year. We have prepared a report on behalf of Petroleum Safety Authority. And the title of that one here is Subsea Facilities, Technology Developments, Incidents, and Future Trends. And saying that, so is that a very broad area, and we also spent a lot of time in order to narrow it in, and had a lot of meetings with the Petroleum Safety Authority in order to narrow it in and also get the focus right, so we are hitting the target, and also are in that line that PSA feel is a contribution to the society. So the background or the content of this presentation here will be background of the whole thing. Norwegian trends versus other regions. There are other regions in the world where we are doing subsea, and we are doing it differently there compared to Norway. We will talk a bit about incidents, integrity management, which was also mentioned by Trond as an important element, future trends, developments, and challenges, and finally, recommendations for improvement of knowledge sharing. It is not easy, but we have some thoughts on it. Okay, the background. First of all, those who have contributed by this report here, Svein Gundersen, project manager, Kari Lønvik, Christian Markussen, Per Wallin, Bente Leindum, and myself. So Svein and Christian is here, so if there are any questions after this presentation, I think they will fill me in. Yes. So what is the background for doing this report, and what is the concern? And we are seeing new and more challenges characterized by increasing number of new subsea wells and also many subjected to life extension, higher pressures and temperatures, pushing the limits, more remote locations, more and more major developments reaches service life, new actors entering into Norwegian continental shelf as being operator. And here, cut it from the PSA's web pages with respect to this meeting here today. Many projects in planning and implementation stages leads to PSA's expectation to high activities in evaluations of older facilities as well as installation of new. So in that big picture, if you are saying that theoretically we are having a fixed number of new fields that is coming up for development, more and more of those fields will in the future be based on a subsea solution, and that means the net contribution of new wells, subsea, will be a higher number year on year, meaning that we are having a kind of exponential increase in number of subsea wells. So that is making the population of subsea wells bigger, and at the same time of that, we are also extending life of those that is already in service. So that in combination of pushing boundaries, extending life, new operators. So are the general questions, are we exposing ourselves to a higher risk level with respect to possible accidents? Purpose of the document, it shall raise awareness to the challenges in the industry, serve as a guideline to new operators and suppliers entering into Norwegian continental shelf, capture lessons learned from about 30 years of subsea development, highlights applied technologies and guidelines for different selection criteria, serve as a guideline for operating a subsea field with organizational aspects as well as being aware of the physical degradation mechanism that exists. Share experience with incident databases and suggested improvements. And finally, the document is written to be educational. So for those who's entering into this industry here, I think there is a lot of learning by reading this document here. So seeing this one here, the purpose of the document, it is really a tall order, and we did our best in order to navigate to fulfill all those requirements. So coming to the content of the document in itself, it says something about technology, historical trends, future trends, developments and challenges both on NCS and globally. An overview of the most serious incidents on NCS and globally. Overview and outlook Norwegian continental shelf and globally. Integrity management, section dedicated to that. Degradation mechanism and failure modes. It is important to be aware of what degradation that is going on in your subsea station, and also what is the failure modes that results into. Inspection, maintenance, and monitoring methodologies. Recommendations for improvement and knowledge sharing. Knowledge sharing was also mentioned by Trond as an important aspect to move this industry further. And I think the more effective we are doing knowledge sharing, the quicker are we developing this industry here to be better, more efficient, and more safe. So in the scope of work for this document here, defining the objects, it is within that red lines here. It is the traditional subsea station elements, the wellhead, the tree, the manifold, the tie-in system, and the umbilical. So back to content of this presentation. Norwegian trends versus other regions. When started with that one here, we had a pretty good understanding of how it looked like, but when you are going to put it on paper, you have to qualify your figures. So therefore, we consulted quite a few databases in order to get a correct picture and also a reliable picture that could be reported and not based on feelings and understanding. It is Quest Offshore, Subsea IQ, Subsea UK, Infield, and not at least NPD's fact pages or Faktahefte. Here are some of the reasons why we are expecting more work in the subsea area. That one here is coming from Rystad Energy, and it shows upstream expenditure growth forecast in the period to come. The blue one here is subsea isolated, while the red one is the remaining part of the upstream expenditure in that period. So for the period of 2012 to 2020, there is an annualized growth in subsea by expenditure by 13%, while the others upstream expenditure is having an annualized growth of 3%. So a bit of how we're doing it on the Norwegian continental shelf and how they're doing it in other regions. If we're comparing those two figures here, I'm seeing here a typical Norwegian way of doing it, where we are having a foundation structure that is serving as the one where we are hanging off the conductor and supporting the drilling loads during drilling operation. With the same support frame or foundation support frame is also supporting the weight of the manifold. The Christmas tree is sitting in here, and the tie-ins are going in here, both with respect to export flow line and also the umbilicals. All protected by a protection structure. A pretty compact unit sitting on the seabed with a relatively limited footprint. The traditional way of doing this one here in other regions, and that one here is taken from Gulf of Mexico, a field that Chevron was developing years back. Here are we having a manifold sitting on its own foundation. We are having the trees sitting as centralized, clustered around it. And here are we having the tie-in points to a pipeline end terminal, and we are having a jumper spool into our manifold. Also here are we having the control systems subsea distribution unit that is controlling or feeding the control modules on the trees and the manifold with power and controls. That one here are also located in here and are then quite often referred to the manifold control module. So that one here is basic different things that we are doing different on in Norway compared to other parts in the world. So, then coming to three concept selections, we're seeing that in the first period, it was the vertical Christmas tree that was dominating the picture in Norway. or the conventional tree, and making the word conventional in its full right. What happened about 98 to about 2000, we had a dominant situation with the horizontal tree concept in Norway. Really a dominant position in that tree selection. When we are looking into the world and installation base of subsea trees and wellheads, we're seeing that there were a trend here where we are having a lot of, or the trend has increased and accumulated with the max figure is it 2009. And we are seeing max figure here about 375 units, and that is what has been reported being on stream. And comparing those figures with forecast figures, so have this industry worked for years with an ambition of having about 500 to 500 sets installed annually, and we are seeing what is actually happening is quite another figure, still a high number, but there's a discrepancy what is forecasted and what is actually installed. Going over to the distribution of subsea wells geographically, we are seeing that we are having NCS here, North Sea UK, Gulf of Mexico, Brazil as the biggest, West Africa, and then we are having Australia here. Comparing trends and selection of technology, we are seeing that we on NCS are pretty unique in the way that we have adopted the horizontal tree concept, where we are seeing a completely opposite situation in Brazil, where the vertical tree or the conventional tree is still the tree that is being used. We are also seeing some of the similar trends in West Africa, while the others or the more mature areas are still very into the vertical tree concept. So that is another uniqueness with Norway, the faith in the horizontal tree concept. So coming over to a bit of the harder things and the tougher things, and also where we struggled the most with this report here, and that is when we are coming to incidents. To get as fair and good picture as possible, we had to consult different databases. It is WODE, Oreda, as many of you, I'm sure, know pretty well. We are having Hendelsesbasen from PSA, Health and Safety Executive from the UK, and we are having Bessie from USA. And we are also having Norwegian Oil and Gas Association and Subsea Installations Network, who is running a lessons learned database. So information extracted from those databases. First of all, we will say that it is considered highly important to establish the root cause and trend the root cause in order to be able to implement correct actions to prevent future incidents. Having an incident, reporting that one there and reading the reports without knowing the root cause is of reduced value. So the root cause is actually very important to be able to have the correct measures in order to avoid corresponding or similar accident in the future. Uncontrolled hydrocarbon leakage may have serious consequences. Other fluids, such as controlled fluid and chemicals, may have impact on the environment in form of pollution and on the operation of the installation. The general observation is that the amount of information in the databases varies and is relatively limited, at least what is public available. There is, of course, people and organizations that knows more about their own incidents and having the full picture of that one there, but what is public available, that is another story. It is limited information available whether the leakage have occurred due to operation outside the design or operation window. The information indicates that leakage often occurs when there is a transient situation, such as drilling, workover, or other intervention activities, and not so much in production mode. And a comment here, we made a comment here yesterday. From an environmental perspective, it is more useful to track consumption of hydraulic fluids per well rather than the number of hydraulic leaks. And that is because of some of those fields are actually having a quite a significant number of liters of consumption of hydraulic fluid. So in the search for information on the largest accident and release of hydrocarbons from subsea facilities, public sources from the national safety authorities has been sought and reviewed. The content of those varies. Clear information on volumes, type of leakage, root cause, etc. is not easy to retrieve. And also, the reports can be quite substantial, and we have to read quite a few of them in order to understand what has happened. However, the information in the databases shows that releases from subsea production system are relatively few and small compared to from other activities, installations, workover, and drilling. The reviewed statistics are based on Petroleum Safety Authority's Hendelses Databasen incident database from Bessie and HSE from British sector. But I think that one here, releases from subsea production systems are relatively few and small. I think that is something that we have to reflect on a bit, so we can be a bit proud of that the subsea station is basically sitting there and doing the job quite safely. When we are interpreting the data, we are seeing there is guidelines and guidewords how you shall characterize your incident. And we are seeing that the one we are having from HSE in the UK and the one in Norway, they are in a way quite confirming to each other. When we are reading them and when we are reading the guidewords and how we are characterizing the different accidents, so are they understood to be a bit different. But the trend is the same, and if there is a trend, or how we shall question that one here, it is by far the unknown one, that is the one who is the biggest. And then is it really an unknown one, or is it that because of we haven't had another category to put it into? Here is the one we got from the authorities in the States. And we are seeing loss of well control here. And when we are seeing that one here, it doesn't tell us much about the root cause. Okay, so general experience from those databases, root cause very hard to find. In many cases, it is not clear to distinguish if the leakage came from a subsea or a topside facility even. The impression is that in many cases, the incident is entered in as an incident, and the information is not updated when the incident has been rectified. So the conclusion is not there. The incident is reported in, but the conclusion is not there. Some are comprehensive in the report format, and several reports has to be examined in detail in order to make a conclusion. So to those incidents that we have been able to retrieve from public sources, from NCS, we are having one in 2013. A bleed valve was set in the open position by a mistake. The estimated oil spill was about 2.5 tons, and we are having the reference here. In 2003, the largest uncontrolled oil spill from NCS subsea installation happened when 500 to 800 meters cubed of oil leaked out due to a rupture in connection between manifold and production line to platform. And that one here is also referred to in the report and also publicly available. From July 2002 until January 2003, about 30 meters cubed was released due to wrong operation of a valve on the manifold, and also that one here documented. UK, 93, there was a leakage from a wellhead on the UK sector where approximately 3.5 meters cubed of oil leaked out. The cause was mechanical failure during shutdown of well, also documented. 96, a tree was leaking about 41.6 tons of gas. The operational causation of the HSR database is dropped object. 96, a leak was discovered during final commissioning of subsea manifold. The root cause was identified as HISC. Also that one here, very well known in the industry. So integrity management. The section of the report describes several aspects: system integrity, subsea integrity management system, life cycle information, barriers. Barriers was also something Trond was picturing quite detailed in previous presentations. Threats, safety philosophy, integrity management process, guidelines and standards for establishing a subsea integration management system. Main challenges related to integrity management in operation. So first, a definition of subsea integrity management. The management of a subsea production system to ensure that it delivers according to the design requirements and national regulations and does not harm life, health, or the environment throughout the required field life. This implies that the operator needs to establish, implement, and maintain a management system that ensures integrity of the system throughout its life. So here we are establishing the integrity system during concept and design and construction, and maintain it during operation. Risk assessment and integrity management planning means inspection, monitoring, and testing, integrity assessment, and mitigation, intervention, and repair throughout, and I would say must also include the final stage. So what else that is during or under integrity management in this report? We have described degradation mechanism. We have identified 15 mechanisms described and explained. Some are also illustrated with photos, and it is done on this form. We are having the degradation mechanism here. Here it is just an example, CO2 corrosion. Is there existing a prediction model in the industry? We are also giving references to what prediction models there are, and also general comment to that degradation. So I said 15 mechanism that is described in the report. When we are coming to thermoplastic and elastomers, also here 15 mechanisms described. What is the degradation mechanism, and also what does it mean, and what is the explanation for it? So I think there's a lot of learning for the industry here to see what is actually in this report here when we come to degradation mechanism. Here are we having examples. Here is a coding breakdown after about 15 years of service. And here are we seeing a galvanic anode totally consumed. But I'm also happy to see and say that one here is totally consumed at the end of service life of this subsea station. So someone has done this job properly. When we are coming to threats, we have identified 69 threats, which is listed, documented, and explained. And that one here is just an example. So here we are just having 2, but there is, as I said, 69 of them. And also that one here, there's a lot of experience transferred, given free to the industry through this report here now. By reading the report, probably a bit too much. But anyway, they are here, and I think it is a good learning for the industry to have access to those here. So, future trends, developments, and challenges. Coming to that area here, I really feel that OG21 with the TTA4 had done a splendid job, making a very good report, talking about the technology gaps for the future. They are tabulating those gaps. They are saying how much it will involve to design them, to test them, to develop them in figures and money, and also what is the time frame for that technology is available to be project selectable. By seeing in this report here, there is a lot of technology gaps that is in the hands of the industry, and also here are those prioritized areas where governmental funding is required in order to get further. Also that report, freely available on the internet, and I think for those who's not familiar with it, download it, look into it. When it comes to technology for the future, I think it is one of the best and most comprehensive documents that is out there at the moment. So a bit of advertising other initiatives that is going on in the industry as well. And that one here is going to be guidelines for how Petromax and Demo is channeling their money, and also be a guideline for Ministry of Petroleum and Energy, how to plan for the political society for this industry in the future. So, standardization for the future. There's no doubt there's a big upside to standardization, both commercially and from a quality point of view. Standardization must go beyond materials and components. Suppliers are more industrialized than operators. Here is there a report that Norwegian Oil and Gas was commissioned to take care of through Kohnkraft with Subsea Installations Network and the contributors here prepared this report here. And I think that one here is a good report. And I think what is said here, standardization enables reduced cost. There's a potential for further cost reduction on equipment, project processes, and documentation for subsea developments. And 6 focus areas are selected: unified specification and QA/QC for subsea forgings, subsea component catalog, universal work order systems, brownfield subsea engineering, standardized subsea documentation, compliance with established equipment standards. So here, both 5 and 1 is now in project phase and actually taken care of by the industry. But I am personally very pleased to see that here, project processes and documentations is also addressed, and not only components and materials. And for those who knows me, they are probably sick and tired of hearing it, but I have an example, and that is the Ford Transit. You can have that as a van, as a lorry, and as a bus, different wheelbases, petrol engine, diesel engine, automatic gearbox, manual gearbox, different door solutions. You can make 15 million transits without making 2, which is the same, and that without taking into consideration the color. And who here would argue that the transit is still not a standard product? So that is a kind of a food for thought. What is standardization? It is something more than just materials and components. I think we doesn't reach to another level with respect to standardization before we are addressing project phase processes and documentation, so that we know what the transaction points should be and look like. So during this report here, I have referred to the databases that we have consulted, but also we interviewed personnel working in this industry, working in oil companies, working at contractor side, and also Norwegian Oil and Gas Association. And I think the engineers, they are pretty much aware of what is going on. And with respect to what is happening now with standardization, they are saying that we have to be a bit careful. The standardization is not a solution to everything, so we have to be a bit conscious of what we are doing. And what is meant by that is that there is a low acceptance for improving design. For the design has already been there, and therefore it is standard, but resulting in replication of former problems. So we have to have improvements processes still. Limited availability of preferred materials within timeframes, resulting in alternative material with unknown track record. Less time and focus on manufacturing, fabrication, follow-up. And also that, again, less acceptance for engineering support to supply and sourcing management. It is a safety-critical industry that we are operating, so even if it is a standard component or a standard project, we need to make sure that we are having engineering support. So, 2 minutes left. Okay, I have to run. Knowledge sharing across competing companies, buyers and sellers is not easy. There exist a real commercial reasons for why knowledge sharing is difficult after incidents. It can be a dispute between buyer and seller. It can be a claim towards an insurer. It would be of great benefit for the industry to have data as comprehensive as possible to allow trending and establishing root cause. From Petroleum Safety Authority, it is the information that shall be reported and what form to fill in. However, all necessary information is not always provided. The subsea industry is today an international industry. The suppliers are international, the design codes are international, and also quite a few of the operators are also operating worldwide. So that should be a good baseline for having a uniform way of reporting incidents. It is recommended and considered of most usefulness and of importance with respect to HSE and equipment development that the industry takes further responsibility for knowledge sharing. First step could be that PSA more clearly define the minimum data that should be reported. Furthermore, the information provided should be more transparent through international databases where useful information can be retrieved. So as a conclusion, the last page, Based on the data from incident database, there is no evidence that the incident frequency is increasing due to the age of the subsea facility. That is very good. Most failures are due to quality issues resulting in early life failures or more random failures. Many of the incidents occurs during transition of operating modes. We view this as human error is an important factor. There is not data to draw any conclusion about incident frequency related to new operators on NCS, which is also good. Dilemma: the more detailed and useful the database is, the less open it would be to public domain. And then finally, the final figure here. What we are seeing in this industry here, where we are having the traditional bathtub curve, is that there's no evidence today to see that we are in that phase here. So if this presentation here is going to be made public afterwards, we have to make sure that that is understood. We are seeing that we are having an early failure rate, and we are seeing we are having a randomized failure rate here, but we doesn't have any evidence to see the bathtub curve increases in failure at the end of it. So my conclusion is that those systems here are maintained for infinite life until the day they are decommissioned. Yes, that was in a rush.
Thank you, Bjørn. Is there any questions for Bjørn and the report from DNV? One here. Sorry. No, it's on.
There we go. Yeah, Christian Markussen, DNV. I was co-author on this. Just a comment, and that is when we're talking about the incidents here, that's related to releases and safety. Obviously, when we're talking about functional integrity maintenance, we do see a trend to have a bit more as the facility age. So, but in terms of safety and environment, we are not seeing any increased trend.
Thank you. Is there any more questions? See Trond here in the front.
Thank you, Bjørn, for a very good presentation. It was on the last slide you had, you said that there's no data to draw any conclusions about incident frequency related to new operators on the Norwegian continental shelf. We have quite a lot of operators on the Norwegian continental shelf, a lot of them with subsea systems. We know that some of the established operators have quite detailed specifications on how to design and install and operate facilities, while the new ones, a lot of them don't have. So with the conclusion you have there, it's probably not very well documented, but still, can you say something around that?
Yes, one thing is that when we are looking into statistics, the population is still pretty small. And also making the statistics more secure, we need more time as well. And also there's a phase lag between what we are recording and what is actually happening. One thing is that what is the incidence, that is one thing, but also is what is the reliability. And also how is it different operators are doing the project phase. For one operator, the whole technical specification for the subsea station is smaller in number of pages than another operator is having a procedure in the contract for how you shall numbering the documents. So there's a completely two different ways of approaching this industry here. And also I think all of those who is in this industry here is doing a qualified job, doing their best to do the very best for their company and the contract and also the project. So I think who is doing what and to what detail level, and also the involvement from operator into the manufacturer's organization is very, very different. So I don't know if that one here is a good answer to it, but also what also has to be considered, which is not part of this report here, and that is Christian's point, what is the availability and the reliability to the subsea station. And if that one there is a significant figure and different from a large operator with a lot of experience or the newer that is coming in. I'm not too sure about that. But what we are seeing is that, for one example, Dong, 12 months after contract award, the subsea station was sitting at the seabed and producing oil. I think that is pretty good. And also then we have also to be careful how we are measuring the speed of doing the project. Are we measuring from decision gate has been done or been taken, or are we measuring from when the PUD is, or PDO is approved, or are we measuring from the contract award when the contractor is awarded? But I think some of those newer companies have done, to me, quite impressive jobs, and the future will, in a way, tell if it has been successful. We don't know that yet, but so far I think it is very good. And also comparing UK sector with Norwegian continental shelf, we are blamed to be expensive here, but we are also seeing that they on UK side are seeing huge, tremendous problem with the FPSOs that is in a way in a worse condition compared to Norway, and that is because of a cheaper product in the first place. So what is the end of the full story? That is something that we can conclude of when the oil industry is over in Norway, I think. But in the meantime, I think the indications that we are having, I think it is, we are doing a good job, but we can, of course, be a lot better. A comprehensive answer. I don't know if I was answering your question, really, but...
I think I'm happy.
Okay.
The only thing is that there are some differences in operating conditions as well that might be different for the various operators.
Yes, and also when we are comparing it, we have to consider there is not a standard oil, there's not a standard gas, there is not a standard field, so there will always be different things that is giving different degradation mechanism, and also inside companies, one project is run very well and another project is not run that well. So it is a lot of factors that is influencing the whole picture.
Okay, thank you for that one. Any more questions? We have time for a few more. Okay.
Thank you for the presentation. Timothy from university, just down the corner. And I based my question on the report carried out by PSA. And the report was on the main contributors to the failures on the Norwegian continental shelf. And there they listed those contributors. They were failure in tubing, in cementing, annual safety valves, so on. There were these three are the major causes. And within your report, can you outline what were the main incident causes in subsea installation equipment?
Those figures that you were referring to there is going back to the scope of this report here, so that downhole and in the well, so that is not part of our work here. So trying to answer those questions here would be not be fair on me with respect to the industry. What is the main incidents, or what is the main factors for why a subsea station doesn't work? If we are looking into reliability figures, I believe that people in the room here would argue that or say that the most frequent failure is in control system. And that is to the operability of the station and the availability to it. But there's no leakage that is happening to sea because of the control system is failing. So we have to be aware of that one there. The biggest contributors have been to material failure, I would say. Either there is springs that is cracking, or there is hubs or pipes that is cracking, or couplers that is cracking.
And just a follow-up question, not clearly related to the presentation, but in your idea for Norway in particular, what are the ideal conditions for going for subsea production, or choosing this concept in respect to the others? What would be your projection on what are the ideal? It could be physical or market or political environment conditions.
Yes, the subsea station in itself, or if you are thinking about subsea or offshore development, subsea station is not sitting there alone. except from Ormen Lange and Snøhvit, are all subsea stations hooked up to a host, to a platform. So then what is being done on the seabed and what is being done on the platform, that will be a different scenario also in the future with respect to subsea process. I believe that we have to look after those who is giving us most for the value. And probably the simplest way of doing subsea process, that is getting rid of the water as quick as possible, as close to the wellhead as possible. I think that is probably one thing that is giving us most added value in the shorter run, and also with a relatively easy handled technology. Also with respect to flow assurance and also having the subsea facility sitting there on the seabed instead of on the platform, saving a riser, saving a pipeline, and also when the condition of separating out the water is the best, when the pressure and temperatures are as high as possible.
Can you foresee the limit for extension from shore for subsea, let's say gas production?
I think those figures are best given in the OG21 TTA4 document, and there is a business case called long well stream transport of gas condensate. I think also fundamental research around understanding cold flow, understanding flow assurance problems for a longer distance. I think that is an area which will contribute to an efficient way of draining hydrocarbons in the future.
Thank you.
Okay, then I think we have to end this presentation. Thank you, Bjørn. It's a little thank you from the PSA.
Thank you.